Hi guys, so yeah, I'm Jaden Furtado. I'm a cybersecurity researcher at R.U.D.R.A Secure, and I'm currently in my third year of computer engineering at Third Shani Engineering College. And yeah, nice to meet you all, and let's get started. So I'm sure we've all seen this in the news, and it's quite common that most people understand or misunderstand what hacking actually means and what it means to be a hacker. Uh, so the news and there's a lot of stigma surrounding hacking as a whole, and I think hackers basically drive forward security and they also drive forward technology. And not everybody should call themselves a hacker. And at this point, I think this word has lost all meaning. So yeah, I mean, that's basically it. That's the meme. And web security is a huge field, and I can't do justice to it all in just around 1 hour of a talk. However, I'll be covering just the basic topics to get started. And I'll try and demonstrate as much of the concepts which I'm trying to explain today. But there's also a possible that I won't really be able to demonstrate everything because I don't really want to, cause any problems like in terms of compromising some company unknowingly. And yeah, I'll be, because of some of the stuff that I'll be showing y'all, please exercise common sense before y'all use it in the real world, because I don't really want to see any of y'all land in trouble. So yeah, let's start with the types of vulnerabilities. And so there's like different types of vulnerabilities as we can see. And we've got OWASP, which is the Open Web Application Security with I don't remember the final word for P, but essentially these guys they anything related to web security they do that. They classify different vulnerabilities. They do a lot of research. It's open sourced, and these I've just put a list of the common vulnerabilities in 2017 and 2021. And as you can see, we've got injection in 2017 was the most common vulnerability. However, it has fallen down to third in 2021, and broken access control has come right on top. And like different vulnerabilities come and they go based on how prominent they are. And so yeah, like this is just to give you all an idea of the types of vulnerabilities which a web application might face. Uh, So yeah, before we actually start going into the security aspects of web security, let's just understand what a website actually is. So can anyone tell me what's a website? Yeah, you're free to unmute, guys. You can even put it on Discord. So, I mean, okay, actually, it's fine. A website is essentially just HTML, CSS, and JavaScript. And it's a bunch of HTML and CSS that is rendered by the web browser, and the rest is just JavaScript which is executed by it. And it may or may not have a middleware and backend as per the requirements. And that's about it. That's all a website actually is. And put simply, you're executing code written by someone else on your machine. And now that's a good thing and a bad thing. It's a good thing when that someone is someone you trust. And it's a bad thing if it is that someone happens to be an attacker, and a lot of things can go wrong. So let's get down to business and let's get some hacking started. So we start with Accessors, which is cross-site scripting. It's the most common vulnerability ever. Uh, we'll start with the DOM. So the DOM is the document object model. It's got HTML, the head tag. In that comes the title. You may have meta tags in the head. You'll have body. In the body comes all the elements of the body, and you'll have different components. Uh, Now, a cross-site scripting attack occurs when someone is able to inject JavaScript into a website. And that's really bad for a number of reasons, because JavaScript is a very powerful language. And there's a ton of things which you can do with it, both good and bad. And what I've put up on the screen at the moment is a flowchart of how a normal cross-site scripting attack occurs. So on the left, you've got an attacker who's injecting JavaScript through the message parameter of your URL. When the person who's like in green, he visits the given URL, that code executes. And in this case, it gives all the sensitive data, the password, transfers money, etc., etc., etc. And this is an example of a reflected XSS. So we'll go into the types of XSS which occur. So yeah, this is another meme which I've put. We've got normal XSS, which is you can have it as reflected or stored. And at the final level, you've got DOM-based and MIME-based XSS. The last two are really difficult to find and exploit, and those are really high-level vulnerabilities. However, keeping in with the nature of today's discussion, I'm only actually going to elaborate in depth on reflected and stored based XSS. Okay, so there's another vulnerability which we could call a vulnerability, if you will, is self XSS. In this case, you're just copying and pasting JavaScript code into the console of your browser, and you need some level of social engineering to pull this off.
Jaden,
Yep.
sorry to interrupt, but for me, the slide is stuck at 2, like for a couple of us, I think.
It's stuck on which one?
On slide 2 for
On
us.
two. Oh.
I think you've gone ahead, but the slide is at 2, I think, for us.
All right. Are my slides visible now?
Yeah, your screen is visible now. Yeah. I think we missed the meme. Can you show that again?
Yeah.
Okay, thank you.
Cool. Okay, I'm probably not going to be able to see the Discord doubts if there are any. So you'll just have to ping me anytime there's a doubt.
Sure, we will.
Okay. So yeah, basically I'll be explaining a lot of the hacking stuff again. Please exercise common sense before you all do anything, because I don't want to be held responsible for anything which you all may or may not do. So yeah, again, types of vulnerabilities. OWASP usually classifies the different vulnerabilities according to their severity in a given year. And as you can see, I've put a comparison between 2017 and 2021. And over the course of just 4 years, different vulnerabilities come and go, and you'll have them in different severities for each year. And I'll be trying and giving you all an overview over most of these vulnerabilities today. However, it's really difficult to cover a lot of this in depth in like 1 hour. And so I'm just going to keep to the basics and try and demonstrate as much as possible. So again, like what is a website? That's something which we need to understand in order to be able to secure one. So a website, as we know it, is just HTML and CSS, which is rendered by the browser. And the rest of it is just a bunch of JavaScript, which is executed. So basically, HTML, CSS, JavaScript, HTML and CSS is rendered by the browser, and JavaScript is executed by it. And you may or may not have a middleware and API as per your requirements. So simply put, you are executing code which is written by someone else on your machine, and a lot of things can go wrong, especially if that someone else happens to be an attacker. So yeah, let's get down to business and let the hacking start. We start with cross-site scripting, simply because that's probably the simplest vulnerability for me to explain. Uh, Before we go into exactly what cross-site scripting is, I think we need to understand the DOM, or the document object model. And any single page which you visit on a website on the internet follows the document object model. And essentially, it is basically a tree, which, as you can see over here, you've got HTML, then you've got inside it the head and the body. In the head tag, you'll have the elements which are the title, which is the title of your website. You can have meta tags in there, which is for stuff like search engine optimization. You can have style tags, which for CSS, which you want to define inside the body. And you can also have link tags and script tags for JavaScript, which you want to include inside your document. We then come to the body, which is exactly as it sounds, the body of your website. And you'll have essentially different elements which are in the body, such as the contents, like the contents of the website. So yeah, what is a cross-site scripting attack? And so essentially, an excess occurs when an attacker is able to inject and execute JavaScript inside a website. That's when it is called an XSS. I have given an example over here. So in this case, this particular website is vulnerable to cross-site scripting. We've got the parameter message, which is the vulnerable parameter. And we can see that the attacker has injected a certain bad script.js file and has sent it to the victim. Now, the moment the victim clicks on this particular URL, this JavaScript executes. And in this case, it is giving whatever sensitive data, his mother's middle name, the wire transfer of money, password, etc., to the attacker. So we can classify XSS into different types. And this is another meme. So yeah. So we can classify it essentially into two types. So it's reflected or it is stored. And there's another way to classify it based on how you're conducting the attack. So it could be a DOM-based attack, or it could be a MIME-based XSS. And both of these are really difficult to find, especially the last one. Especially because you need access to the source code of the website in order to be able to effectively find these. So the first one I'll get into is a self-XSS. And I don't know how many of you all have done an inspect element for Facebook's and Gmail's pages. If I had to open Facebook's a Facebook page and do an inspect element of it, you would see that Facebook has a certain alert box which pops up saying, stop, please don't do paste anything in here, because it could be a malicious JavaScript code which executes and gives people access to that person's authentication tokens. In fact, I'll even try and show it to you all live. So facebook.com, do Control-Shift-I, and there we go. So if you can see over here, we've got this browser feature is intended for developers. If someone has told you to copy paste something, beware, like it could be a cross-site scripting attack, and they've given a link to self-XSS for more information. So that's basically what a cross-site scripting attack could do. You basically do the attack on yourself, and you need some degree of social engineering to be able to pull this off successfully. We then come to reflected cross-site scripting. This occurs due to improper sanitization on the front end. Still needs some degree of social engineering to be able to pull off. It is a little more severe than self-XSS, simply because the victim will almost certainly not be able to tell that something is happening to them. And okay, you could argue in some ways that it is a type of self-XSS because the victim still has to click on that particular link for the malicious JavaScript to execute. And this happens to be probably the most disrespected vulnerability ever, especially by security teams, simply because when it comes to triaging reflected XSS, most of them just play it off as being insignificant. And that I can't really blame them for it. I blame the researchers who flag reflected XSS, especially if you use an alert box to do so. And I'll get into this when a little later in the slideshow. And yeah, we've got DOM-based XSS. These are difficult to find. You need access to the source code to be able to find them. And you need a sink, essentially that's the terminology we use, such as an eval function or set in our HTML function. And what these do is they execute code dynamically. And that's what makes a DOM-based accessors difficult to find in the first place, because you need access to the source code. And it's also really difficult to exploit because, well, they're difficult to find. And so, yeah. So what if I told you there's more to cross-site scripting than just an alert box? So most people just use alert1 to demonstrate a cross-site scripting attack. But if you want, like if you're in a bug bounty program and you want the security team to take you seriously, you have to go beyond an alert1 and show them the true scope of your vulnerability. And cross-site scripting attacks are usually best used for stealing cookies. And if for those who don't know what a cookie is basically like an ID card given to you by the server. And every time you go to a particular website where you have the cookies, you just show them the cookie, and the server will say, okay, I know such and so had this cookie, which means this is such and so, and I should give him access to that person's data. Now the problem is if an attacker gets access to your cookies, he could show the same cookies to the server. The server will go, okay, so I had given this cookie to XYZ. I have received this cookie back. Only XYZ had access to this cookie, and it would mean that this is XYZ, and I have to give person XYZ's data to, in this case, the attacker. And that's how cookie stealing attacks work, and you can do them using cross-site scripting attacks. Another interesting attack vector which you can exploit through cross-site scripting is a denial of service. So, okay, this is the only image I could actually find for a denial of service using cross-site scripting. It's in, I believe it's in Spanish or Latin, but it gets the point across of what I'm trying to say. So you've got all of these users who are pinging this particular server because of the cross-site scripting iframe, which has been injected into the website. And it's really, really difficult to protect against such an attack simply because it is taking place on the client side. And it has the added advantage, I would say, from the attacker's perspective, in that you could basically spoil the reputation of a particular company using this kind of attack. And so, yeah, basically, if company, that's my server, and hackers, that's our server. And so this is the things we can do with a cross-site scripting attack. You can deface a site. You can do a cross-site request forgery, which is, like I said, stealing cookies. You can do a denial of service. You can sniff passwords, like capture passwords, and you can take over accounts, because the moment you've got either the password or the cookies, the entire person's account is in your control. And so, yeah, I'll demonstrate a few of them. Let's see if I can find a few. This is a simple search bar that I've put over here. What this does is effectively take in any value I give it. Let's just say Jaden, and on clicking submit, it will just echo the same value outside. And I think I can show you the code. So yeah, this is the code, and it's a simple PHP page. There's nothing really special about it. It's just a form. It's got an input field, a text field, and it will echo the search value. Now, the interesting thing is if I put something like JavaScript, the script, and alert1. I think you can see, right? Localhost says alert1. Now, going back to the one slide which I had shown initially, if you want a security team to take you seriously, you need to go beyond this alert1. So what you could do is say document body dot inner HTML equals hello world. And now what I have done is essentially defaced the website. And I've replaced the contents of the body with hello world. But I want to take this even further. Like I'm really down to business and I want the security teams to patch this at once. So what I could do is inject an iframe. And this will be really interesting if I'm able to pull this off in a live demonstration. So source http host /fbui clone this is a bit irritating. We'll give it a style. We say that we want 100% viewport width. And I also want a height of 100% viewport height. Yeah, great. Okay, I didn't think it would execute, but it did. So now this looks like the login, the sign up page or the login page of Facebook, right? But interestingly, this isn't really built by Facebook. This sign up page is under my control and it belongs to me. And it's a perfect replica of Facebook sign up page. And if I had to give this to someone who, let's just say, trusted me, and let's just say it belonged to some person who, this link belonged to some website, which let's just say you trusted, and I had to send you this link, and you didn't really know anything about cross-site scripting. The probability that you would fill up this page is really high. And the moment you actually just sign up something over here, all of that data goes to the attacker. And that's the power of reflected accessors in this case. And you can take this even further, like I have just shown you so much. You can start doing a denial of service attack against this. You can start sniffing people's passwords. That's another interesting thing which I've come across. So the page you're seeing currently is again vulnerable to a stored cross-site scripting attack. I won't go into how I exploited it, but essentially the only thing you need to know is the submit button, right? It looks very innocent, but the moment you click on it, do you see this? admin@123. That's the password for the admin account of this website. And a good question would be now, how exactly did I get it? So if I show you the code, you'll see there's a small script tag over here. I'm filling, there are also two input fields. We've got one email input field and one password input field. And both of them I've set the style attribute to display none, which means they're going to be hidden. And what I'm doing is I'm using jQuery JavaScript to retrieve the value which is going to be filled over here and send it via Ajax to the URL of my choosing. Ajax, for those of you who don't know what Ajax is asynchronous JavaScript execution. And this means I'm able to just capture this person's password just by filling in the most likely value for the email field. Simply because Chrome automatically fills the password field for me, especially if you use Chrome to store your passwords. So yeah, if you're doing that, be a little careful because such things could happen. And just because I have not actually written the code for capturing the stored password, I'm doing a console.log for the data, which is over here. Just to prove that I have access to the password. And so yeah, like every time I click on submit, I think it should automatically keep on giving me the password. So that's all about cross-site scripting, and let's go further. All right, so cross-site scripting done. We now come to SQL injection. It's another type of code injection vulnerability. Uh, I think the meme is pretty self-explanatory. You got a genie saying you have 3 rules: no wishing for death, no falling in love, and no bringing back dead people. And the person is just saying like, okay, great, semicolon, drop table rules, and you comment out the rest of the part. And now the genie says there are 0 rules. And that's basically how SQL injection vulnerability works. So before we go into what is SQL injection, what is SQL? So SQL is structured query language. We use it for inserting data and retrieving data from databases. And there are different types of SQL. So you could have MySQL, you've got Oracle, you've got PostgreSQL, or even NoSQL like MongoDB, etc. And no matter what, the main principle behind it is the same. You want to input, retrieve, retrieve, manipulate, and delete data in a database. And that's what it is used for. And so how it works. So this is SQL statement. SQL is pretty simple for those of you who've never worked with it before. In this case, I'm selecting ID, name, image from the table named anima models, where the category is equal to the category, which is my input, ordered by, well, the order. In this case will be the ascending order. And I'm using MySQLi underscore query to retrieve the database. I mean, retrieve the data from the database. And I'm, in this case, printing out the statement, printing out my result. This is PHP for those of you who don't know. And I think it's really simple as a starting example. However, there's also something which you can see that there's a lot of ways it can go wrong. And so how can it be abused? So instead of just giving, like in the previous slide, category equals 4, I could put something like category equals 4, then a colon, not a colon, an apostrophe, and then say union. Select username, email, and password from the table named users. I'm then going to put a semicolon, which closes off the statement. So it can't be executed anymore. You've got the dash dash, which is the comment for SQL. And I still have to take care of the first apostrophe, which is in the select statement. And which is why I've got another apostrophe, a semicolon apostrophe. And basically what this does is it will stack tables, the data of tables, one on top of the other. And you can start retrieving data from different tables. You can insert data into different tables which are not intended, intended for your use. And you can compromise the entire database of an organization. I have seen cases in my time as a security researcher where people have gone all the way from normal SQL injections to getting entire reverse shells on servers. And a reverse shell, for those of you who don't know, is essentially like, I open up command prompt. It is kind of like this, except this is for my laptop, but you would have something like this for the server, the web server, the vulnerable web server. And from that point on, may God have mercy on the organization, because most hackers don't. And so yeah, what is an SQL injection? It occurs when you inject SQL into a website. You can classify SQL injection, just like cross-site scripting, into different types. So you've got error-based SQL injections. You've got blind SQL injections. Uh, Blind SQL injections are really interesting because they are timing based. So SQL has basically a condition checker, and based on the condition, you can delay your response. So for example, if I say, if the user in the table users is equal to admin, return the response after 5 seconds. But if it is not equal to admin, return it after 10 seconds. So at the moment I get my response after 5 seconds, I know that at least one user in the table is equal to admin. Otherwise, it's admin is not an entry in the table users. And that's like an example of a blind SQL injection. Out of band is again really interesting. Out of band SQL injection simply means that you're not really able to retrieve data the same way as you inject it. And basically you have to go out and be a little creative in exploiting out-of-band SQL injections. So you'll have to output it to a file, or you'll have to use your SQL server to ping another server, or do a DNS lookup. And those are really interesting stuff, which I won't go into because for the lack of time. And SQL injections back in the day were really prominent, and I'm talking like in the 80s and the 90s. Uh, because SQL injections in themselves were really just a really new field. And now, of course, as people are becoming more aware of them, they are less common, less frequent, but they are still common. Like you could use Google to find SQL websites which are vulnerable to SQL injections. And so, yeah, going from the example which I gave, select name, comma description from products where category equals gifts. And what the attacker has done is replace the parameter with his union-based stuff. So he's also retrieving the username and password from the table users. And because there's no sanitization of the input, the server is just going to perform it and it's going to execute. And a good question would be, how do you prevent an SQL injection? You prevent an SQL injection using these things called prepared statements. And I'll show you how prepared statements are written. So this is an example in PHP again, which has no prepared statements. So you just do MySQLi query, create table test, ID integer, or label text, etc. You're directly executing the SQL queries which you want to run. However, this is really insecure because in the example of create table test, if you're taking in the value from the users, there's a really high chance that you could suffer an SQL injection. A better way to do it would be through prepared statements. And what prepared statements effectively does is, if you look at the first line of code of PHP, that is $statement is equal to $mysqli prepare, and you've got the SQL query insert into tests ID comma label and the values. In this case, the question marks are your parameters. And what you want to do is, as you go down, I think you can see $ID is equal to 1 or $label is equal to PHP. And you're binding the parameters to essentially the question marks. And the good thing about this is that PHP's own internal libraries will do the sanitizing work for you. So you don't have to do it yourself. And the good thing is, because PHP is like, they've really tried and tested it before they put it into use for everyone, the probability of an SQL injection is close to none. And so yeah, please use prepared statements if you are building a CRUD app, that's create, retrieve, update, and delete, just to be like on the safe side. And so yeah, this is an example of what an error-based SQL injection would look like. Obviously, I can't show you the exact SQL injection. This is of a real website, by the way. I've just taken a screenshot. I've hidden the URL because it is still vulnerable, and I don't want any SQL injection from any of the people who are watching me present at the moment. I don't want to land in trouble. But essentially, what I've done is pretty simple. If I go back to this example, I've done something very similar to this. All right, I've just put in an extra apostrophe. And what that has done is it has broken the entire SQL query. And okay, it's a really complex query. And if you're not familiar with SQL, it looks like, okay, what the heck is this? But it isn't really that complex. You've just basically put in an extra apostrophe where SQL wasn't really expecting one. And it has just thrown you the entire SQL statement out. And it's really easy to bypass. And yeah, you can essentially compromise this entire company's website. Uh, I could give you a few examples of cross SQL injection. Let's see. Okay, so I thought of building my own website for an SQL injection. However, I have managed to break the database. So I'm going to go with Portswigger Labs. For those of you who want to get into hacking, like I would definitely recommend going through your Portswigger Web Academy. Like it's a really good place to start for getting a foothold into hacking. So yeah, in this case, I know that this is definitely vulnerable to SQL injection. I can test it out by putting a simple apostrophe over here. And yeah, the moment I put an apostrophe, I get an internal server error. The moment I remove my apostrophe, it works just fine. Now a good question would be, why is this turning out to be %27? The thing is, every time you put in any special characters, unless yeah, like a question mark or an equal to or a slash, HTML will encode them so that it doesn't break the HTTP headers as you're transporting it through the different OSI layer models. Just to get really technical. But yeah, so if you want to put space, you'll just do a plus. You'll say union, select, I think it's username, password. And I don't know if this will run. Great. So yeah, so what I've done is now select null null. What that would indicate is that whatever data is being fetched from the backend has two columns. Now I want to retrieve data from different tables. A good guess from me, an educated guess, would be you would have one column named username. Another column most likely would be named passwords. And I'm going to take an educated guess again and say that the table name will be users. And great. Okay, it retrieved it. I was not expecting it, but fine. So yeah, the username is administrator. The password is whatever the password is in this case. Again, another username is Veena, and his password is also given over here. Then you've got the normal data which is being retrieved, and we've got a third user who is Carlos, and Carlos's password is given below here. And so yeah, this is an example of a union-based SQL injection. I've conducted it over here, and I should, in fact, even just take you all to the lab description. And for those of you who want to like get into web security, go through Portswigger Labs. Like they are amazing. Like they'll go in much more depth than I'm able to at the moment. And it's a good place to go for further reference. Anyway, let's continue. So broken access control. Now, access control is exactly as it sounds. You want to limit access to certain users based on who they are. So you wouldn't want to give user A access to user B's account and vice versa. At the same time, you wouldn't want to give a normal user administrative privileges, right? I mean, it makes no sense if you do that. Uh, Sometimes, in fact, I'd say most times, when you've got like a company who is really low on budget and they've got to meet deadlines. The people they hire will try and cut corners just to meet the deadlines. What that often means is things like as simple as access control are often missed. And that leads to some really interesting results. So in the picture which you can see right now in front of you, the attacker has got access to the account menu of this user AB1234, and they can start transferring money to their own account. And they've also got, in this case, for insecurewebsite.com, they've got administrative access, and they can start deleting users. So yeah, what is broken access control? So access control is the application of constraints, and so that you can control who has access to particular resources. And authentication identifies that a particular user, and it confirms that they are who they say they are. Or session management, like it identifies subsequent HTTP requests and whether they are being made by the same user or not. And broken access control is, unfortunately, it is a common occurrence, and they are almost always critical vulnerabilities. And so yeah, this is an example of something that I found. This is a website which belongs to the government of India. I'm not going to go into who they are or what they do. And I had to blur out a lot of the critical information. But essentially, this is exactly what I was talking about. They've got the login page and they've got the admin page. Unfortunately, these guys didn't actually think about checking whether a person is logged in when they go to the admin page. And that has left the admin page entirely open for anyone to see on the plain internet, including myself. And that's how I got the screenshot. And yeah, I've reported it, of course. But so yeah, the point is like it happens a lot, and it's difficult to find. But if you know where to look for them, it's not that difficult. Usually it'll be like /admin or something, and you'll just get access to the entire administrative panel. And so yeah, in short, one does not simply do access control. You have to be really careful how you handle your authentication and access control flow. And if you don't, this might happen where you've got entire access to the administrative panel. And so yeah, don't just stop at this. All right, you can go much further. You can start getting like reverse shells, which is exactly like I said. You've got remote access to a computer, and you just got to keep pushing the boundaries of what you can do with your hacking skills. Yeah, now we go to security misconfiguration, which was also like a real common vulnerability in OWASP sheets. When you misconfigure your server and you don't do proper testing, this is like a common vulnerability. I would classify it as a vulnerability. It can cause all sorts of crazy problems that most people don't foresee. It's incredibly easy to detect for an attacker. It's rather difficult to detect for the programmer, and they are, again, usually critical. Again, this is something I found. So on the right, in the screenshot, you will see that this particular application has their configuration file exposed over the internet. And what that has done is you've got the application key, which basically is used for encrypting and decrypting session cookies, is exposed. You can already see that the application has been left in debug mode because I think like the third entry is app_debug is true. You can even see in the application log level is set to debug. I've got the username and password of the database. I've got, I don't know what else, the username, I mean the email address, the email ID, the password of the system administrator. And I've cropped out most of it, but one of the other interesting things that I found was the Github API tokens. And what that means is I've got complete access to this company's GitHub repositories, and I can start pushing my own code into them, or start pulling the source code and start looking for additional vulnerabilities. And so yeah, like just be careful before you deploy anything to production, because if you don't, the things like the previous slide might happen. So yeah, rigorous testing is super important before deploying anything into production. Yeah, now we go to sensitive data exposure. And it overlaps with a lot of what I've previously said, but you're again exposing really sensitive information. And it could be accidental, or in some cases it could be unlawful, where you basically just compromise the database and you've got access to stuff that you shouldn't have got access to. And so yeah, this is a classic example. You've got Hmac, which is hash-based message authentication for all parameters, and you just leak the encryption key. And all of a sudden, everything that you've done is pretty much rendered useless, because anyone can decrypt the messages. For those of you who are wondering what is Hmac, so this is just a flow diagram of what it actually is. I'm not quite sure if it came in. But essentially what this is you've got a message, okay? You're splitting the message into different sections. You're hashing it. You're taking a hash of each section. Let's just say the hash has n bits. You're putting the message and you're encrypting the message and the hash together with the key, and you send it. And when the receiver gets it, he just reverses the entire process, checks whether the hash actually matches or not. And if it matches, it means that the message is coming from the source, from the person they claim to be, and not from someone else. But the problem is, the moment you've leaked the key, this entire process is pretty much rendered useless, because anybody could claim to be someone else, and you've basically just compromised the entire system. And so yeah, coming back to the previous slide, don't leak the encryption key. And here's another example. If you look on the right in the screenshot, you've got all sorts of usernames and passwords, and these were stored in a password.txt file on this website, which I found. And so yeah, like you've got all the usernames and passwords of the system administrator, and it's not very nice. And so yeah, just like be careful on what data you're exposing on your websites. This is another example. Like I've just blurred out this entire page, but from the little which is visible, you should be able to see that you've got exposed Google OAuth tokens. And if you've got Google, if you're using OAuth of Google to sign up and sign in users, like using something like Firebase or Google OAuth, or even Facebook and Instagram and stuff, like be really careful how you're storing the tokens. Because if you don't, what happens is someone else might come along and you've got all of this. And in this case, I had full access to these people's calendar, because they had given this particular application access to their Google Calendar. I had access to their Gmail accounts, so I could basically just see people's emails or write emails for them. And essentially, you've also got access to a lot of other things which I don't think anyone would want to give some stranger access to. So yeah, like be careful on what data you're storing and how you're storing it, because it's really embarrassing if that happens to you, or to your application, that it just leaks data of the users. And so yeah, data leaks, they happen all the time, happen to the best of us, including Facebook and Google and Instagram and stuff. But yeah, be careful on how you're storing data. Okay, now we come to using insecure code. And for most of the application developers, including me, we just like to pick up code from a place like Stack Overflow or GitHub and use it in our application. In fact, many a times I've seen people using Node modules, and most of them don't even know what those Node modules do, but they are still basically included, and they are using them in their application. And in some cases, some Node modules need other Node modules as dependencies, which is why they are installed. And you basically, it just causes a big mess, and most people don't really know what is going into their code base. Now it's a good thing if you just want your code to work, like, and you don't really care about the security aspects of stuff. But you should care about the security aspects of your code, simply because if you don't, I'm sure you'll have heard about Log4j, right? It's been in the news like from the last 2 or 3 months. And that happens when you use insecure code, when you put stuff in your code base that you don't really understand yourself and you don't take time to validate. And so, yeah, it is extremely convenient. I agree. I've been there Googling like till 12 o'clock at night, trying to find a solution on Stack Overflow. But is it actually worth it? Like, do you really need to do that without validating what you're doing? And it can, again, cause all sorts of problems. A good example would be Log4j, where I know for a fact companies had it in their code base and they didn't even know they were using it. And the way they found out they were using it is when their customer data was found being sold on the dark web, which is not very nice. So yeah, always validate your code before you use it. Yeah, connecting devices to the internet. Again, unless you absolutely need to connect something to the internet, do not connect it to the internet. All right, like it's a very, very bad idea. And this is the fastest way to get foothold inside an organization. When you've got like an exposed printer or an exposed, I don't know, an Internet of Things device, which most people are like, oh, that's really cool. You've got like lights which are controlled by your phone. And you've basically connected them to the internet, and some random hacker comes along and basically gets full access to your house. That's not something you would want. And you can, I've given an example over here using Google. If you had just Google, even right now, Untitled webcam XP flash JPEG stream, the result would be you'd get a lot of devices which are connected on the internet, which are cameras. And I have given one such example of a thing which I have hacked. This is a webcam of, I believe it's an Eastern European country, and I had access to their security cameras on the streets, and I've just taken a screenshot. And yeah, it's quite insane, some of the stuff that you can pull off, especially with Internet of Things devices. So if it should not be on the internet, it should not be on the internet. Don't connect it. So yeah. Okay, now coming for the programmers, how do you defend against hackers? Like, how would I protect myself if I was a coder from my application getting hacked? So this is how you don't do it. One is client-side input validation only. I've just given an example. That's the result of what happens when you just put it on the client side and you don't take care to validate it on the server side too. Mostly because client side stuff can be bypassed really easily. Okay. So yeah, how do you defend against hackers in that case? So first of all, always validate. Like just, I can't emphasize that enough. Like validate, validate, validate. Uh, 90% of all vulnerabilities can be avoided if you validate your code again and again. And not just code, also user input. Just don't trust your users. Rule number one of being in coding, do not trust your users. Uh, don't hit copy and paste for your code. And I think the meme explains it properly. There's enough vulnerabilities already there in your code base, and you don't really need to add more to them. Sanitize all inputs. Okay. Again, the meme explains it very well. So you're not sanitizing user inputs, and so yeah, he likes to live dangerously. Uh, Structure your code properly. Like from the moment you decide to build something, I would say like architect your code using keeping security in mind. That's a common mistake people make is to say like, okay, I need to get my code to production, and therefore I'm not going to take any security considerations at the moment, and we'll do it once we start scaling our application. The problem with that approach is you've already ignored security at the very start, and it probably means when you start scaling, you're going to ignore it in the future as well. Also, to be secure, and companies like Google and Facebook, they do this. The moment they decide to start building something, they'll have security considerations like, okay, we don't want user XYZ to have access to user ABC's data, and here's how we're going to do it. And so, yeah, from the very start, keep security in mind, and that's how you structure your code. And always test before deploying your code to production, and don't cut corners. It is not worth it, especially once you'll start going into companies and you'll start working with them. Please test your code before deploying to production. And it's the easiest way to like catch vulnerabilities. Like at least you'll catch it in testing, and hopefully it does not occur in production. And so yeah, what happens if all of this fails and your app ends up getting hacked? Uh, so yeah, if you're lucky enough to get a disclosure, be nice to the person disclosing your vulnerabilities, because I've seen it in a couple of cases where uh, the company has not been nice to the hacker for disclosing the vulnerability responsibly. And then the hacker goes like, okay, I'll show you all too, and essentially dump stuff on the dark web. And that's really embarrassing if it happens to your company. So like, be nice to the hackers. Accept your mistakes. If someone says you've got a vulnerability, you've got a vulnerability, just patch it up. Yeah, and ensure you don't make the same mistake in the future. And so now what? So what I've been able to cover thus far is less than 1% of what is possible in the domain of web security itself. And web security is a huge field, like I said at the start. So keep yourself curious. Like it's always important to keep learning. Try new frameworks. Like there are new things coming out every day, especially for the web. Learn new languages, like see how they can be vulnerable to different attacks, learn how to defend against them, hack things responsibly. Uh, Please don't abuse some of the things which I've shown y'all, and yeah, teach others and have fun. And yeah, thank you for listening, and I hope you were able to learn a few things from me. And so yeah, looking forward to your feedback. And that's all from me. Thank you.
Yeah, that was a great workshop, Jaden. You can see all the claps coming in on MS Teams. Yeah, so if anybody has any doubts, you can ask him on Discord, and we'll be sharing a feedback form shortly. Please fill that up, because Jaden, what you explained was mind blowing. Like all of these things, like I didn't even know like we could still do this. Like there's so much to be done. And yeah, so if you guys have any doubts, you can ask now, or you can also put them in the feedback form that we're going to share right now on Discord. And yeah, let me just finish. Yeah, so okay, thank you for coming to the workshop. Thank you, Jaden. Thank you to R.U.D.R.A. And yeah, you guys can leave. We'll be sharing the feedback form.